Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. This video is video number 4 in our series on RNAV GPS approaches. In this video, we'll take a look at how to fly RNAV GPS approaches that have advisory vertical guidance instead of approved vertical guidance. We'll take a look at how these approaches differ from the LP+V type approaches we've been flying in the last few videos, and then get in the air and demonstrate how to fly one. Before you begin this video, it's a good idea to be familiar with the basics of instrument flying as well as the basics of flying instrument approaches. You'll also want to be familiar with the basics of how to operate the GPS receiver you're using, whether that's the Garmin G1000 or the Garmin GNS 530 or 430. You'll also want to be familiar with the basics of how RNAV GPS approaches work, which we covered in video 1 of this series, and you'll want to be familiar with how to fly an LP+V type of RNAV GPS approach using the receiver of your choice, as the technique for flying the type of approach we're looking at today is very similar to how you fly an LP+V approach. As usual, I'll leave a link to all these videos and playlists in this video's description. So what are RNAV GPS approaches with advisory vertical guidance? With the LP+V type approaches and with LNAV+V type approaches, you receive both lateral and vertical guidance from the GPS to fly the approach, and both the lateral and vertical guidance are what we call approved guidance. You fly these approaches in the same way you would fly an ILS, following the lateral and vertical guidance provided by the GPS down to a decision altitude, where you either acquire the runway visually and land, or go missed approach when you reach your decision altitude if you don't acquire the runway visually. But there are some types of GPS approaches that are designed without approved vertical guidance. These include LP approaches, where the lateral course narrows like a localizer, and LNAV approaches, where the course remains at a constant 0.3 nautical miles wide from the final approach fix to the missed approach point. When you fly these approaches with certain GPS receivers, including the G1000 and the GNS 530 or 430, you'll still get approved lateral guidance that you can follow to fly the approach. But the GPS will also provide you with a glide path you can follow as well. This glide path is not approved vertical guidance, meaning that the FAA has not designed the approach to be used with vertical guidance. So this glide path is considered advisory vertical guidance rather than approved vertical guidance. Having an approach with this advisory vertical guidance creates the LP+V and LNAV+V type of approaches. While these approaches are very similar to LP+V and LNAV+V type approaches, there are a few key differences. First, it's important to note that the LP+V and LNAV+V approaches are not approach types that are recognized by the FAA, so you won't find any LP+V or LNAV+V minimums on approach plates. You're simply flying either an LP approach or an LNAV approach with a GPS that happens to give you a glide path to follow, so you'll use the minimums for the LP or LNAV approaches. Second, LP and LNAV approaches use a minimum descent altitude or MDA rather than a decision altitude or DA. Since we can't go even 1 foot below an MDA, if we want to fly our +V type approaches, like an ILS, and follow the glide path down to minimums before we either land or miss the approach, we need to add in a little buffer. So we'll add 50 feet to our MDA and call it a derived decision altitude or DDA. Second, it's important to recognize that LP and LNAV type approaches have higher minimums than do LP+V approaches. LP+V approach minimums tend to be close to 250 feet above the touchdown zone elevation, which is pretty close to the minimums you see on most ILS approaches. Minimums on LP approaches tend to be just a few hundred feet higher than those on LP+V approaches, but the minimums for LNAV type approaches can be quite a bit higher. Since you're going to be at a higher altitude above the field when you reach the DDA on these types of approaches than when you would reach a decision altitude on an LP+V or ILS approach, you'll also be farther away from the runway when you arrive at that DDA. This can create a problem since the visibility minimums can often be lower than the distance you'll be from the field when you get to that DDA, meaning that you may not be able to get the field in sight when you reach your minimums. Let's take a look at some examples. So let's take a look at the RNAV GPS approach into runway 35 in North Little Rock. The identifier in that field is Kilo Oscar Romeo Kilo. We have an LNAV type approach, which we can shoot as an LNAV+V approach. It has an MDA of 960 feet for category A and B aircraft, visibility minimum of 1 statute mile, and then the height above touchdown of our MDA is going to be 415 feet. So if we want to use the LNAV+V technique to fly the approach and follow that advisory glide path, we'll need to create a DDA by adding 50 feet to our MDA. So that is going to give us a DDA of 1,010 feet MSL, and that is a height above touchdown of 465 feet. So how high or how far away from the runway are we if we're on a 3-degree glide slope or a 3.05 degree glide slope when we're at 465 feet above the runway at that DDA? Well, we know from the FAA climb descent table that for every mile we move away from the runway on a 3-degree glide slope, and this is 3.05 degrees, so we'll call it close enough for government work, that for every mile we move away from the runway will be 318 feet higher above the touchdown zone elevation. So at 465 feet, we divide that by 318. That means we're going to be 1.5 nautical miles away from the runway when we arrive at that DDA. Again, the visibility is minimum is 1 statute mile. So if the visibility is actually 1 mile, and we're 1.5 nautical miles away from the runway when we reach our DDA, we may not be able to see the runway from our DDA. Let's take a look at another example that will be a little bit higher minimums. All right, so let's take a look at the RNAV GPS to runway 3 at Petit Jean Park, which is just to the west of Morrilton. Identifier there is Kilo Mike Papa Juliet, and this is the approach we'll actually be flying later on in the video. So it does have an LNAV minimums here for category A and B aircraft. The MDA is going to be 1,620 feet MSL. The visibility minimums is 1 nautical or 1 statute mile. And then the height above touchdown of this MDA is going to be 714 feet. Again, if we're going to fly this with the LNAV+V technique, we're going to have to add a buffer to this MDA to create a DDA. So we add 50 feet. We get a DDA of 1670. That's a height above touchdown of 764 feet. So if, again, I look at how far away I'm going to be from the runway, if I'm on a 3-degree glide slope at 764 feet above the runway, I'm 318 feet for every nautical mile I am away from the runway. I'm 318 feet higher for each mile. So divide 764 by 318. That means that the DDA on this approach, I'm going to be roughly 2.4 nautical miles away from the runway when I reach that DDA. This is kind of a WAG. I'm not accounting for the threshold crossing height or the difference between nautical miles distance I'm going to be on the approach versus the statute mile visibility that was required for the approach. But if the visibility is 1 nautical mile or 1 statute mile, and I'm almost 2.5 miles away from the runway when I reach my DDA, odds are I'm not going to be able to see the approach. So what do we do about that? To counter this problem and give ourselves a better chance of seeing the runway on the approach, we can use the technique of flying the advisory glide path to our DDA, then leveling off at the DDA and flying forward to the missed approach point before executing the missed approach, which is usually located at the runway threshold on a straight-in RNAV GPS approach. This is a legal technique since we're allowed to level as low as the MDA and don't need to execute the missed approach until arriving at the missed approach point. If you're using an autopilot to fly the approach, you can just press the altitude hold button and increase your power to maintain your approach speed. If you need to do this, just be aware that the closer you get to the runway, the more likely it is that you'll be too high to make a safe descent to the runway using normal maneuvers and a normal rate of descent. So even if you get the runway in sight somewhere past the DDA, you may still need to go missed approach if you're too high. Another thing we need to be aware of on these types of approaches is that since the glide path is advisory in nature, it doesn't guarantee that you're going to clear any step-down fixes on the approach. Although most approaches are designed so that you will, you do need to monitor your altitude as you descend and make sure that you meet those step-down altitudes and adjust your flight path as necessary if it appears that you won't. So an example of this is on the RNAV GPS to runway 27 into Carlisle Municipal in Carlisle, Arkansas. Identifier on that airport is 4 Mike 3. You can see we have a LNAV type approach here. If we're flying this using the LP+V type technique, then we would intercept the glide path at 2000 at the Sivkey intersection. We would ride that down to a DDA of 690, but we do have a steps down fix here at Waxon intersection, which is 2 nautical miles from the end of the runway. We need to cross that fix at or above 920 feet MSL. Again, most approaches are designed so that you will do this, so you can just ride down the glide path, watch your altimeter as you cross over Waxon, which will be a fix on the approach. In your GPS, just make sure that you're at or above 920 feet. If it looks like you're descending at a rate on the glide path that will put you below 920 feet, then you'll need to intervene and take it out of approach mode, probably put it in a vertical speed mode, shallow out that descent. Make sure you cross Waxon at or above 920 feet. Then you can continue your descent after that down to your DDA of 690. Finally, another feature that approaches that don't have approved vertical guidance may include is a visual descent point, or VDP. This is depicted with a bold black V on the profile view of the chart. A VDP is a visual descent point, which is a point on the final approach course of a non-precision approach from which a normal descent from the MDA to the runway touchdown point may be commenced. Flying beyond the VDP at MDA may result in the aircraft being too high to make a normal descent to landing. In other words, you may need to go missed approach if you fly much beyond the VDP at MDA, even if you get the runway in sight. So you can think of the VDP as kind of a warning point on the approach. It's basically saying if you reach this point and you don't have anything in sight, it is legal to level at your DDA and fly forward to the missed approach point. But if you've reached this point and you're not still descending, then it may be you may be too high, and even if you see something, you may be too high to safely descend with a normal rate of descent to the runway. So they're saying if you get to this point and you don't have something in sight, even if you see something, you may have to go missed approach anyway. Usually the VDP is located on most GPS approaches where the minimums and the glide path will intersect. So you should be able to fly this down to your DDA, and about when you get to your DDA, you should be at that visual descent point, be able to see something, and continue your descent without having to stop. But if you do reach this point and have to level, you need to be aware that most likely, even if you see something, you're going to be too high to make a safe descent from there. So now that we've looked at the basics of how this type of approach works, let's hop in the aircraft and take a short flight to demonstrate how to fly it. We'll conduct a short IFR flight in the G1000 equipped Cessna 172 from Conway Regional Airport in Conway, Arkansas. The identifier on that field is Kilo Charlie X-Ray Whiskey to Petit Jean Park Airport that's located in Mount Petit Jean State Park just to the west of Morrilton, Arkansas. The identifier on that airport is Kilo Mike Papa Juliet. We'll plan to fly the RNAV GPS to runway 3 at Petit Jean Park, which is an LNAV only approach. After departing Conway, we'll navigate direct to Fapin Waypoint, which is one of the initial approach fixes for this approach. Our filed route will be Conway Airport, direct to Fapin Intersection, direct to Mount Petit Jean Airport, though in real life, you could probably just file direct between the two airports and then let ATC know once airborne that you plan to start the approach at Fapin. We'll file for an altitude of 4,000 feet, which is above the off-route obstacle clearance altitude for this area and the terminal arrival altitude for this area that we'll be in as we begin the approach. The flight is just over 35 track miles and should take about 20 minutes to fly in the Cessna 172. We'll plan to depart runway 22 at Conway. We've checked the takeoff and departure procedures for the airport, and there is an obstacle DP that requires us to make a turn to 260 after departure, and then hold that heading to 1,300 feet MSL before proceeding on course. There's also a minimum climb gradient that needs to be met on departure, and the 172 will easily meet it. We'll assume that the weather at Conway is good enough that we can get back in and that we feel comfortable departing. Petit Jean Park Airport is a unique airfield in that it's located on the top of Mount Petit Jean, which is about 500 feet above the surrounding terrain in this area of the Arkansas River Valley. Another wrinkle for this approach is that while the real-world airport has pilot-controlled runway lighting, that lighting is missing in Microsoft Flight Simulator, so we'll have to assume that it's been NOTAMed out of service for this flight. Runway lighting is actually not required to fly an instrument approach. The airport does not have any sort of approach lighting system, and there's not a requirement to adjust the visibility on an instrument approach for inoperative runway lighting. But it will make the airport a little more difficult to pick up visually in low visibility conditions. There's also no weather reporting available at Petit Jean Park Airport, but the weather reports from Conway and Russellville indicate we should expect calm winds, visibility of 1 nautical mile, a ceiling of 800 overcast, and temperature and dew point around 14 degrees C. We'll use Russellville's altimeter setting, which is 2992. So let's take a look at the approach plate for this approach and take a look at the things we need to be aware of as we prepare to shoot this approach. So up at the top right, it gives us the title for the procedure. It is the RNAV GPS to runway 3 at Petit Jean Park, which is an FAA identifier of Mike Papa Juliet. ICAO identifier will be Kilo Mike Papa Juliet, and it is listed in the Airport Facility Directory and the Terminal Procedures publication under Morrilton, Arkansas, so that's where we need to look to find things like departure procedures for this airport. It tells us that the approach course is 026, and it gives us a runway landing length of 5,414 feet, which is plenty long for our 172. Tells us that the touchdown zone elevation for this runway, for runway 3, is going to be 906 feet MSL, and that the airport elevation is 923 feet. It tells us that there's something non-standard about departing this airport under IFR. So if we need to depart under IFR, we'll need to go into the TERPs and look that up. And then it tells us that this airport is not available as an alternate, most likely due to the lack of weather reporting here. Since it does not have any sort of weather reporting at this airport, it tells us that we need to use the Russellville altimeter settings, which again we are assuming is 2992. Also tells us that the procedure is not available, not authorized at night. So we cannot fly this instrument approach at night. It would be difficult since the approach lights since the runway lighting is not active to even land under VFR at night at this airport. It tells us that a GPS system is required that has 0.3 nautical mile accuracy, and both the G1000 and the GNS 530 and 430 are capable of that. Also tells us that a DME type RNAV system is not authorized for use, even if it does have that 0.3 nautical mile accuracy. It tells us that the missed approach procedure is to climb straight ahead to 3,500 feet via a 026 course to Upake waypoint and hold. And that is what is depicted here on the plan view. Go straight out to this intersection and enter the missed approach hold. It tells us that the controlling agency for this airport and for this approach is Memphis Center, gives a frequency for that. And it lets us know that the common traffic advisory, where we need to make our radio position calls, is 122.9. So that's where we want to flip over to once we have been handed off from center to go to the local common traffic advisory frequency. The L tells us that in real life this airport has pilot controlled runway lighting, but again this is an op in Flight Simulator. So looking at the plan view of this chart, we have the Arkansas River depicted here along with a couple of small lakes in the area. And then we have our tallest obstacle over to the northwest corner of the approach plate at 1,940 feet, far enough away and not from the direction that we're coming, so that's not really a factor. It also has several smaller obstacles closer to the runway that are between 1,100 feet and 1,300 feet MSL, so good to be aware of that. It also has terminal arrival areas for each of the initial approach fixes here and the intermediate fix. We're going to be approaching the Fapen intersection from this direction over here. So we'll be flying in from the east, northeast, relative to Fapen, almost due east of the airport itself. And so we will be in this terminal arrival area here. And this tells us once we're within 30 nautical miles of Fapen and proceeding direct to Fapen, once we're cleared for the approach, we can go ahead and descend to this altitude. As we depart Conway, we will actually be about 20 miles or less from Fapen as we're making the departure from Conway. So we will be in this terminal arrival area, which means once we're cleared for the approach, we can go ahead and descend down to 3,500 feet. As far as how we're going to proceed in on the rest of the approach, we'll hit Fapen, and then it will sequence to Jetsy intersection, and we'll fly this intermediate segment here. It tells us that the procedure altitude for this segment is 3,500 feet, so we don't need to go down anymore. It tells us that we do not need to do this procedure turn here if we're flying this intermediate segment here, so we don't need to worry about that. And it tells us that this segment is 5 miles long. Once we hit Jetsy, which is the intermediate fix, again, no procedure turn, we'll turn straight to Totsy, and the GPS will sequence to Totsy, which is the final approach fix. So we'll proceed inbound on the 026 course, and the segment altitude on this segment of the approach is 2,600 feet. So we can go ahead and descend down to 2,600 feet once we sequence from Jetsy to Totsy, and the segment is 5.8 miles long. So the way we'll probably fly this is to descend probably a little more rapidly than a 3-degree descent, probably 600-700 feet per minute to get down to 2,600 feet. At that point, we'll be about 3 miles away from our final approach fix. So we'll go ahead and configure for the approach. We'll arm the approach on the autopilot, and then we'll fly to Totsy, intercept the glide path, and fly down to the DDA. And we'll talk in more detail about that technique here in just a little bit. Looking at the plan view here, it tells us that if we're in the holding pattern, we need to be at 3,500 feet prior to getting to Jetsy. That is not applicable to us. Once we pass Jetsy, then we'll go ahead and descend down to 2,600 feet. Again, it gives us the distance on this segment. And then once we hit Totsy, we'll go ahead and intercept that glide path and write it down to our derived decision altitude. It tells us that the glide path on this approach is 3 degrees, and it tells us that the threshold crossing height, if we stay on that 3-degree glide path, will be 45 feet above the touchdown zone elevation. The missed approach point is RW03, which is at a waypoint that's located at the threshold of the runway. Once we get there, we can go ahead and execute that missed approach, and it does have that missed approach visually depicted for us here, straight ahead to 3,500 feet. Go to Upake intersection and hold. It again gives us the runway elevation, 923 feet, the touchdown zone elevation of 906 feet. It shows us that there are PAPIs on each end of the runway. These are also missing from Microsoft Flight Simulator, so they are not present as well. So we'll consider them NOTAMed out of service, and that does not have any effect on our approach. We can see that we have a little bit of a runway displaced threshold here. The runway is 5,852 feet long by 75 feet wide, but that displaced threshold is why we have a landing distance that is slightly less than that. Shows us where the approach course comes in from, and it shows us that the approach course is 026 coming in from the final approach fix to runway 3, and we can see it's pretty much a straight in, dead straight in approach. It does tell us that, again, in real life, the runway has medium intensity runway lighting, but again, that is pilot controlled, but again, that is missing from the airport and flight simulator. So looking at the minimums for the approach, again, it is LNAV only. So we have an MDA. The MDA for a Category A aircraft, which is what we are in the Cessna 172, is 1,620 feet MSL. And that is a height above touchdown of 714 feet. And then the visibility minimum is 1 statute mile to fly the approach and be able to land from the approach. Again, if we're flying it with the LNAV+V technique, we need to add a buffer in there and create a DDA. So we will take our MDA of 1,620 feet, we will add 50 feet, and that will give us a derived decision altitude, or DDA, of 1,670 feet MSL. That is a height above touchdown zone now of 764 feet. Again, with that height above touchdown, if we arrive at 1670 on the glide slope, we're going to be about 2.5 miles away from the runway with a reported visibility of 1 statute mile. That means we probably won't be able to see the airport when we arrive at the DDA. So we will use the technique of leveling at the DDA and flying forward. So let's talk a little bit about the specific technique we're going to use to descend on the glide slope and level at the DDA. So again, we're going to hit JETSI at about at 3,500 feet, and then we'll descend to 2,600 feet. And when we arrive at 2,600 feet, then we'll probably be about 3 miles away from the final approach fix from the intercept of the glide slope at Totsi intersection. So we'll already be at a reduced power setting for the descent. So likely what we'll do is just make a small adjustment of power or leave the power where it is once the aircraft levels to allow it to slow and configure. So what that's going to look like is once we get to 2,600 feet, we'll adjust the power to about 1,800 RPMs. Again, it might be a very small adjustment depending on what power setting we were using for the descent. Once we are below 110 knots, which we should be even in the descent, we'll go ahead and bring our flaps to 10 degrees, so that should happen almost immediately. Then once we are at 85 knots, again, we'll allow the aircraft to slow with that reduced power setting and the 10 degrees of flaps. Once we get to 85, we'll bring the flaps to 30 degrees, 1 notch at a time. And then once we are at 70 knots, actually it'll be about 75 knots that you'll want to bring the power back in. And that's going to be about 2,200 to 2,400 RPM to maintain level flight at 2,600 feet at 70 knots. And once you're stabilized in level flight at 70 knots, then you want to perform your before landing checklists. And then you'll want to do whatever you want to do with the autopilot and the flight director. I do recommend on this approach flying this with the autopilot since you are leveling. It is a very high workload situation, so that's probably the recommended procedure, is to use both the autopilot and the flight director. But you could fly this with just the flight director, or you could fly it with no autopilot, no flight director if you want. I'll also mention that when you level at 2,600 feet and start configuring, or once you are configured, that's a good time to arm the approach mode on the autopilot. That's what you want to do to get the autopilot to follow both the lateral and vertical guidance. It is a glide slope, or a glide path rather. It is not considered VNAV guidance. It is considered a glide path. So you do want to arm the approach mode and not the VNAV mode to follow that glide path. So once we intercept the glide path, this is going to look very much like an LP+V approach or an ILS approach until we get to the DDA. So we're going to, as we intercept the glide path, reduce power to start the descent. Again, just like with the ILS and the LP+V approaches, about 1,800 to 2,000 RPM in the 172 should hold that glide path, that 3-degree glide path at 70 knots. We'll make adjustments as necessary from there. If we're hand flying, we want to make small changes in pitch, power, and heading to track the lateral guidance and stay on the glide path on speed. And then we'll track that guidance and the glide path to the derived decision altitude. Again, with this approach, we're going to level at decision altitude because it's unlikely we'll have the airport in sight at this point. So we'll go ahead and level at the DDA to see if we can go a little further forward to see the field. So what that's going to look like is that when we arrive at the DDA, we'll increase pitch and power to hold altitude at the DDA and at a speed of 70 knots. This is going to be a power setting very similar to what we had at the platform altitude prior to Totsi intersection and prior to the intercepting the glide path. It should be about 2,200 to 2,400 RPM to hold our altitude at the DDA and at a speed of 70 knots. If you're using the autopilot and the flight director, you can use the altitude hold function to hold the altitude for you, and then all you have to worry about is the power. Then you're going to fly forward until you get the runway environment in sight for the visual landing. Then you can kick off the autopilot, reduce the power, and descend to the runway, or You can fly to the missed approach point and execute the missed approach procedure if you get no visual, or if you're too high to make a safe visual descent using normal maneuvers and a normal rate of descent. One note I do want to make about the missed approach procedure is that you cannot start the lateral portion of the missed approach procedure until you actually get to the missed approach point. You need to continue to follow the lateral guidance for the approach until you get to that missed approach point. You can start your climb at any time if you decide to go missed approach, but you're not guaranteed obstacle clearance unless you stay on that approach path until you get to the missed approach point. Then you can sequence the GPS to the missed approach guidance and follow the missed approach guidance from there. So when should you execute a missed approach on this type of approach? It is a little bit different than your standard precision approach. You need to miss the approach if you have not acquired the required visual references, the runway environment, by the time you reach the missed approach point. If the aircraft is not in a position to make a safe descent to landing using normal maneuvers or a normal rate of descent, in other words, if you are too high, even if you get things in sight prior to the missed approach point, if you're too high to make that safe descent, then you need to execute that missed approach. If the required visual references are lost anytime you descend below the MDA, then you need to execute that missed approach. And then if you get full-scale deviation on the lateral or vertical guidance without the runway environment in sight, and again with a check ride, you're only allowed a 3/4 scale deflection before that is considered a bust. And if the approach becomes unstabilized, you should go ahead and execute the missed approach. If any required component of the approach or the onboard equipment becomes inoperative, if you get a GPS integrity warning or something like that, then you should go ahead and go missed approach. And then anytime it becomes unsafe, in your opinion, as the pilot in command, to continue the approach, kind of the catch-all, that anything you deem as unsafe, you can go ahead and execute the missed approach, and the examiner will generally accept that if you explain to them what you thought was unsafe. All right, so looking at the setup for the flight, we'll go from the world map and work our way from the top left over to the right like we usually do. For aircraft selection, you do want the Cessna 172 Skyhawk G1000, although you can shoot this in the 172 Classic if you have that aircraft. We'll talk a little bit about how to program the GPS on that before we get airborne. And then the Arista Blue is just a third-party livery I have, so don't worry if you don't see that. You should just see the Cessna 172 Skyhawk G1000. Liveries, you can do what you want with that. Weight and balance, I've got it set up for 2 full tanks and 2 passengers in the front, and then failures, you don't want any in customization as you would like it. And then we'll just select our departure airport. So we will go from Kilo Charlie X-Ray Whiskey, which is Cantrell. So we will select that. And then you can either start on runway 22 if you'd like, or you can start on the ramp. Either one is fine. I will select the ramp so we can get everything set up. And then as far as flight conditions, I've got it set for a mid-June day at noon for lighting conditions. We'll set up the weather in the simulator, and we're done with that. And then I will set the actually set the time on the bottom left so it sets the time accurately there. So we've got that all set up. That's everything we'll do in this menu. And now we'll go ahead and click on fly and get into the session. Okay, as far as the weather setup, we do have our general settings set to an altitude calculation of AMSL, so we don't have a varying cloud base. No precipitation, we don't want to add any additional restrictions to visibility other than what we have with the cloud cover. No snow depth or lightning. We've got the temperature set at about 60 degrees, so about standard, and the pressure at the standard 2992 with a 1 on the humidity, which is as low as it will go. Any higher than that, and again, you're going to have a little bit of a restriction to visibility. As far as the cloud settings, we do have an overcast cloud coverage, so 100%. Density I've set at 0.5. That should give us roughly 1 mile of visibility. We do have the scatter set at 0, although with an overcast cloud cover, that won't really matter that much what you put in there. Got the altitude tops at about 11,000 feet, so we don't break out. And then we've got the altitude bottoms at 700 feet. Minimums on the approach are 1620, actually it'd be 1670 with the DDA. So we set that roughly 1,000 feet underneath what our minimums are, and that should have us breaking out and getting some visibility at that altitude when we get down to our DDA. So that's how we want to set up the weather. Let's take a look at how to set up the aircraft for the flight. All right, so we've got the aircraft started up. We'll go ahead and load the procedure into the G1000. In the G1000, we don't need to load any sort of a flight plan or anything like that. You could load a flight plan between the two airports, or you could just go direct to the destination airport, but you can also just load the procedure from the procedure page. So we'll push the procedure key here. It's already highlighted select approach, so we'll hit enter. I'm going to use the keyboard function here, and we'll enter our destination, which is Kilo Mike Papa Juliet, and that is Petit Jean Park at Morrilton, Arkansas. We'll hit enter. That will swing us down to the approach field to give us the list of the approaches. The only IFR approach is the RNAV GPS to 3, and you can see in here it gives us the title here that says it is an LNAV+V, so it's the LNAV with that advisory vertical guidance. We'll go ahead and hit enter to load that up. It asks us where we're going to start the approach. We'll use the big key to scroll down to Fapin intersection and then hit enter. It asks us if you want to set up our minimums. I'll go ahead and use the small knob to turn that to Barrow, and then I'll go ahead and enter the minimums here. It's less I have to do later, and roll that up to 1620. Once we have that loaded in there, I'll hit enter again. That'll take me down to the activate field. There is actually 1670 will be our DDA. So I'll hit enter. It takes me down to the sequence of fixes here, so I'll look through, make sure those look correct. We have Fapin, Jetsy, Totsi, runway 3, and then we have a climb to 1,323 feet before we go direct to Upake intersection, and then we've got the hold in there. So all that looks good. It all looks correct. And we'll go ahead and hit activate and enter, and that will load everything in the flight plan. Everything looks good there. And it's going direct. When we hit activate, that loads direct to the first fix on the approach. So we're good to go there. We can see all the fixes look good in our flight plan. We'll go ahead and key that off. We can see also that we've got our route displayed up here on our moving map. So everything looks good. And as I mentioned earlier, you'll notice that our distance from the first fix, Fapin, is only 19.3 nautical miles from where we are right now. So we're actually already in that terminal arrival area. So we can go ahead and use those altitudes. We'll probably climb to 4,000 and then get a clearance down to get a clearance for the approach once we get about 10 miles away from that fix. But if we wanted to, fly at 3,500 in flight sim, we would be perfectly safe in doing that. Now let's take a quick look at how to set this up on the GNS 530 and 430. Then we'll come back into the G1000 cockpit and talk about setting up our autopilot and other systems. If you want to load this in the GNS 530 or 430, I recommend loading the flight plan first. It can just be an airport-to-airport flight plan, so KCXW to KMPJ, and that will make loading the procedure, well, it will make your CDI work better. It does have an error right now that if you just load it with the procedure page or load just direct to MPG, it will show a flag down here. So if you want this to work correctly, start with the flight plan, load that flight plan, again, just the 2 points, the 2 airports in there, and then go to procedures, and then go to select approach, and it shows you the only approach available is the RNAV GPS to runway 3. It does not have the visual approaches in here. You can see it also does not say +V, but it is still a +V. It still will give you vertical guidance. So go ahead and hit enter. Then it goes down to the transition. Where do you want to start? Again, just like the G1000, go down to Fapin, hit enter, and then we use the big knob to scroll from load to activate. And again, activate will take us directly to the first point on the approach. We hit enter, and we can then see the waypoints: Fapin, Jetsy, Totsi, runway 3, a missed approach turn point, and the missed approach holding fix. So all of that looks good. Of course, we'll want to do other things like set up our altitude pre-select and our autopilot, set up your heading for departure, just like we're going to do in the 172 G1000 edition. And then the approach flies pretty much the same with the GNS 530 as it does with the 430. So the technique between the 2 airplanes is going to be exactly the same. It's just a matter of, it looking a little bit different in this GPS versus the G1000. So back to the G1000, as far as setting up the systems for the rest of the flight, I'm going to go ahead and get my autopilot or flight director stuff set up, my AFCF stuff set up. What I'm going to do here on the heading is I'm going to enter that heading of 260 to give myself a reminder that once I get airborne, I want to get up to 400 feet and then make that turn to 260 in complying with the obstacle departure procedure. So that is loaded in there. Our altitude is going to be 4,000, so go ahead and put that in the altitude pre-select on the autopilot there. Want to make sure that my GPS is active in my HSI, so I have that to navigate with. And then I'm also going to turn on my bugs here let's see, I'm going to reset this to my approach speed. I will turn that on when I get after the takeoff, and then I'll go ahead and get the bugs on. Let's see here. I will turn that off for now because I don't need that until I get into the approach phase, but I will have the bugs on for VR, VX, and VY for my takeoff. Already set the baro minimums for the approach when I loaded the approach, so I don't have to worry about that. So that, I believe, is everything we need to set up for the autopilot to have it all ready to go once we take off. Now we need to call and get our clearance. So Conway does have a clearance delivery frequency that we can reach on the ground in real life. So in real life, we would call up that frequency and look for our IFR clearance. And they call us back and they say Cessna 172 Golf Hotel cleared to Petit Jean Park as filed. Intercontrolled airspace heading 260, climb and maintain 4,000 feet, departure frequency 119.5, squawk 5502. So we read that back, and then they either give us a hold for release or give us a clearance void time. And so then we will get everything entered as far as the transponder code and that sort of stuff, and then go ahead and taxi out, do our run-up, and get airborne. When we're ready to go and we have our IFR release, we'll perform a normal takeoff from runway 22 at Conway. When we reach 400 feet AGL, which is about 680 feet on our altimeter, we'll make the turn to 260 degrees to comply with the obstacle departure procedure. So once we're airborne and clear of the traffic pattern, we'll go ahead and call up Little Rock Approach. They call back and they say Cessna 172 Golf Hotel, radar contact. Proceed direct Fapin intersection, climb and maintain 4,000. And so we read that back, and we have 4,000 already set into the altitude pre-select there, so we'll climb in the autopilot flight level change mode there, and then I'll go ahead and use the GPS and go direct to Fapin. That's preloaded in there for me, so I press the direct key, Fapin's preloaded, hit enter, and then activate, and that sends us direct to Fapin. I can go ahead and hit the nav on the GPS controls, or excuse me, on the autopilot controls, and get it headed that direction. So we'll climb up to 4,000 feet. We will cruise out the airplane, and then we'll start getting ready for the approach. And as I get cruised out at 4,000 feet, Little Rock Approach hands us off to Memphis Center, so we'll make that switch. When we check in with Memphis Center says, Cessna 172 Golf Hotel, Roger. You are 10 miles from Fapin intersection. Maintain 3,500 until established on the approach. You're cleared for the RNAV GPS runway 3, Mount Petit Jean Park. So we read that back. We're cleared for the approach. We take a look at the chart, and we are within 30 nautical miles of Fapin, so we're in that terminal arrival area that's 3,500 feet. So we will go ahead and bring our altitude pre-select down to 3,500 feet. We'll do a vertical speed descent, so I'll press the vertical speed button and nose it down to about 500 feet a minute, then pull the throttle back to keep my indicated airspeed at about 105 or so. And we'll go down to that altitude. So after that, we're just navigating to Fapin, and then the segment from Fapin to Jetsy is also at 3,500 feet. So we will just fly that level at 3,500 feet, and then we'll proceed on in on the approach from there. So as again on this initial segment from Fapin to Jetsy, I'm going to go ahead and get ready for the next segment. If I look at the profile view, I can see on the next segment, I'm going to go down to 2,600 feet. So I'll go ahead and roll the altitude pre-select down to 2,600 feet to get ready for that segment. And again, that's a fairly short segment. It's only 5.8 nautical miles for me to get down to 2,600 feet, which is 1,000 feet, and to configure through the approach. So I'm going to be a little more aggressive on that descent than I am normally. Instead of using like 500 feet per minute, I'm probably going to use 700, 800 feet per minute to get on down there. And then once I level at 2,600 feet, I'll probably be about 3 miles away from Totsi intersection, my final approach fix, and my glide slope intercept point. So at that point, I will go ahead and once I level, I'll start configuring for the approach. All right, so I've started the turn at Jetsy intersection. We'll wait till that segment turns magenta, and then we will go ahead and start our descent. So there's the magenta segment there. That means we're established on that segment. I'm going to go ahead and put in again about 700 to 800 foot per minute descent, again using the throttle to control my speed. I'll get on down to 2,600 feet, and then we'll take a look at our distance once we level there at 2,600 feet and start to configure for the approach. All right, so I'm coming up on 2,600 feet. I'm still about 3.5 nautical miles away from the glide slope intercept point, so I'm going to go ahead and bring the power back in momentarily to about 2,400 RPMs, 2,450, something like that. Actually, there's 3.0 nautical miles, so I'll go ahead and bring the power back to about 1,800. I'm going to bring that first notch of flaps out and start configuring the aircraft for the approach. Once I get to 85, I'll bring the rest of the flaps out. Get on that approach speed, then we'll do the before landing checklist. So there's 85 knots, there's another notch of flaps, and then one more notch of flaps, about 75. I'll go ahead and bring that power back up to about 2,400, 2,200 to 2,400 RPM. Looks like 22 is going to be a little closer to keeping me on 70 knots. We'll go ahead and hit the before landing checklist, and I want to go ahead and arm the approach mode. So everything is ready. The glide slope is coming down. I'm going to reset my timer reference bug here so that I have a reference for my approach speed. I'll go ahead and get rid of the rotation speed. Don't need that on the approach. Looks like right at 2,200 RPMs is holding my 70 knots. I don't want to go below that, so I'll add a little bit of power in there. And we're just waiting for that glide slope to come down. The approach mode is armed. We can tell by the glide path armed enunciation here. So then we'll just ride the glide path down to our derived decision altitude of 1670. And then if we don't see anything at that point, we'll go ahead and hit the altitude hold and bring the power back in to see if we can go forward a little further towards the missed approach point and pick up the runway. Watching my vertical speed is the first indication that I've captured the glide path. And the glide path indicates capture. There goes my vertical speed. You can see my airspeed is starting to increase, so I'll decrease that power to somewhere between 1,800 and 2,000 RPMs is usually about what it takes. So we're established on the glide path. I'm going to go ahead and enter my missed approach altitude in my altitude pre-select, so it's all set up in case I have to go missed approach. Now I'm just allowing the autopilot to track the lateral and vertical guidance. I'm using the throttle to manage the speed. And again, once I get to about 1670, I'm going to hit the altitude hold button, bring the power back in, and I'm going to take a look up and see what we see. You can see as we get close to our minimums, the minimum bug starts moving up on the altitude tape. And when it gets exactly centered up with the altimeter, that's when I want to hit the altitude hold and bring that power in. About 100 feet above, I'll go ahead and take a look outside. So there's 1770. No visual. So we'll go ahead and hit the altitude hold button as that bug centers up. Bug is centering up, so we're going into altitude hold, bringing the power in so that we don't get too slow. Again, about 2200 to 2400 RPM is what we're looking for. And then I'm looking out front to see if I get any indications of the runway being out there. Being aware this whole time that if I get too close to the runway, I may have to go missed approach anyway. I'm about 1.5 miles away from the runway, and I'm seeing the runway markings coming into view. So I'll kick that autopilot down, reduce the power. I can go ahead and descend below MDA. I'm going to need a little more aggressive a descent than I would need for a normal approach, but I don't want to get excessive. So no more than 1,000 feet a minute. I'm just going to point my nose towards the run numbers here and keep the power in so I'm at the approach speed. Unfortunately, we don't have PAPI on this runway either, so we don't have any guidance as to whether we're high or low. We can keep our eye on that electronic glide path. You can see it's kind of scooting up from the bottom. You can see my approach or my descent rate's about 600, 700 feet per minute, a little higher than I would have on a normal instrument approach, but not excessive or unsafe. So that's how we fly our LNAV+V approach if you have advisory glide path information. So when can you consider yourself proficient at these approaches? You kind of have to cobble together standards for these approaches from both Task A and B of Area Operations 6 from the Airman Certification Standards for the instrument rating. Task A is the non-precision approaches and Task B is the precision approaches, and it kind of has elements of both. When you're prior to the final approach fix, it's just like any other approach. You need to be able to maintain your altitude plus or minus 100 feet, maintain your heading plus or minus 10 degrees, maintain your airspeed plus or minus 10 knots, and then accurately track radials, courses, and bearings. Generally, anything outside or inside of full-scale deflection is not considered a bust. And then from the final approach fix to the missed approach point, you need to be able to maintain a stabilized approach. They don't want to see an excessive rate of descent. Allow no more than 3/4 scale deflection of your lateral or vertical course guidance until you get to that DDA. Again, anything under 3/4 scale deflection is not considered a bust, and it's not considered a bust if you approach 3/4 scale deflection and execute the missed approach. Should be able to maintain your approach speed, airspeed plus or minus 10 knots. And then once you level off at that DDA, you need to be able to maintain that MDA altitude plus 100 minus 0 feet. And again, you get zero tolerance on the MDA. You cannot go 1 foot under that MDA, which is why we create a DDA and why we put that buffer in there so that you have a little bit of wiggle room so that you don't go underneath that MDA. Then you should be able to transition to a visual approach using a normal rate of descent or normally maneuvering once you have the runway environment in sight, or execute the missed approach whenever it is appropriate. That concludes this video. Hopefully it's given you the knowledge and skills you need to confidently fly LNAV+V and LP+V RNAV GPS procedures on your own. As always, if you've enjoyed the content, don't forget to like the video, share it with your friends, subscribe to the channel, and ring the notification bell to be alerted to new content. Thanks for watching, and we'll see you next time.